The last two lessons explored how to choose the correct statistical test. Now we're moving to the next step. How do you interpret the result from a statistical test to determine significance, and how would you report it? When asked to explain whether results of a test were significant, often in conjunction with justifying why a certain test was performed, which relates to the 3Ds covered in the previous lessons, the following need to be considered: the direction, one or two-tailed, the number or degrees of freedom, and the level of significance. You will then consult a critical values table provided to you to determine whether a test result is significant. Every test produces a calculated value, sometimes also called the observed value. To decide if that value shows a real effect or just random chance, you compare it to a critical value taken from a statistical table. You will be given all the information you need in the exam. You won't need to calculate anything except the sign test covered in the next lesson. In order to determine whether we need to use a one or two-tail test, we need to look at the hypothesis. An experimental or alternative hypothesis predicts that there will be a significant effect. Something is going on. If the hypothesis is directional, like saying one condition will score higher or lower, respond faster or slower, etc., basically indicating a direction, then we use a one-tailed test. If the hypothesis is non-directional, simply predicting a difference of some kind without stating the direction, we use a two-tailed test. The null hypothesis predicts no significant difference. Any variation will be due to chance. So in other words, a one-tailed test comes from a directional hypothesis where we predict a specific outcome. For example, drinking coffee makes you more alert. A two-tailed test comes from a non-directional hypothesis where we only say drinking coffee affects alertness without predicting how. So the tail refers to whether the researcher is testing one specific direction or both possible directions. Use the hypothefish reference as a memory aid. Have a look at this hypothesis and determine the direction. You can pause if you need a minute to think, and then I'll tell you the answer. So in this case, the hypothesis is directional, therefore we need a one-tailed test. Let's now have a look at levels of significance. If you rolled a dice 10 times and got 5 heads and 5 tails, that's very likely due to chance. But if you got 10 heads and 0 tails, that outcome is much less likely. It might indicate something unusual is happening, like a biased coin or magical powers. That's exactly what inferential testing tells us, how likely it is that our results are due to chance. The p-value tells us the probability that our result occurred by chance. In psychology, we usually use a significance level of p equals 2 or smaller than 0.05, which means we're 95% confident our result is genuine and accept a 5% risk that is due to chance. So when you see p equals 2 or smaller than 0.05, it literally means there's less than a 1 in 20 probability that this result happened by chance. Researchers don't always use the same significance level though. It depends on the context and how serious it will be to make a false conclusion. 0.05 is the standard in psychology, offering a balanced, cautious level of confidence. 0.01 is a stricter level, often used in medical, clinical, or high-stakes research where we want to be 99% confident in our findings. 0.1 is a looser level, sometimes used in exploratory or replication studies where previous findings already suggest an effect. As the p-value threshold becomes smaller, so stricter, we reduce the risk of a type 1 error, which is a false positive, but we increase the risk of a type 2 error, which is missing a real effect. I will explore that in more detail in lesson 5. What is the p-value in this example? Well, this is made clear in the text itself, where it states 5%. So the p-value is smaller than or equals to 0.05. We're saying that we'll accept a 5% probability that our results are due to chance. Let's look at one last ingredient now that we will need to determine significance: the number or degrees of freedom. Spearman's Rowe and Wilcoxon use the number of participants. Mann-Whitney uses the number in each group, and the sign test uses a number as well that you will figure out how to calculate in lesson 4. And then the remaining tests use degrees of freedom. You don't have to learn the formula for these. They will be in the exam paper, not the formulas, but the actual degrees of freedom. What is our degrees of freedom here then? Again, this is made clear in the text itself. It states 9. If degrees of freedom isn't stated, but it says something like number of participants, then we're dealing with Spearman's, Wilcoxon, or Mann-Whitney, where in a straightforward way you use the number of participants, or in Mann-Whitney, as I said, the number of participants in each group. Just to summarize, when reporting a statistical test, you'll need to know the direction, the p-value, and the number or degrees of freedom. Every test produces a calculated value. You don't need to know how to work this out, except for the sign test. So, again, this is clearly stated. For this t-test, it's 1.4377. Now that we know our test is one-tailed, given that it literally states directional hypothesis, the p-value is smaller than or equals to 0.05, and the degrees of freedom is 9, we can look up the critical value for this t-test from the critical values table provided. In this case, the critical value is 1.833. How do we know if our results are significant then? We need to compare the calculated value to the critical value. For some tests, significance is achieved when the calculated value is greater than or equal to the critical value. For others, it's when the calculated value is less than or equal to the critical value. The exam paper will tell you which applies. You don't have to memorize the rules. For the t-test, the calculated value must be equal to or greater than the critical value. However, our calculated value of 1.4377 is smaller than the critical value of 1.833. Therefore, the result is not significant. This means we have to accept the null hypothesis. There's not enough evidence to say there's a real effect. When you report a statistical test, use this formula in the exam. I highly recommend memorizing it so that you don't forget to mention anything that's important to gain all marks. For a 1 or 2-tail test, where the p-value is so-and-so and the number or degrees of freedom is so-and-so, the calculated value, so-and-so, is greater than or less than or equals to the critical value, so-and-so. So the result is significant or not significant. The null hypothesis is therefore accepted or rejected, and the alternative hypothesis is accepted or rejected, meaning that so-and-so. So let's use our example to see what this looks like in practice. For a 1-tail test, where p equals to or smaller than 0.05 and the degrees of freedom is 9, the calculated value, 1.4377, is less than the critical value, 1.833. So the result is not significant. The null hypothesis is therefore accepted, meaning that there's no significant effect of so-and-so on so-and-so. Let's practice interpreting the kind of question you might see in an exam. You're told the test is 2-tailed, that the probability level is 5%, and the number is 9. Your job is to find the critical value compared to your calculated value and decide if it's significant. Have a go at this now. Hopefully the information you found is the same as I found. How would you answer the question now? Use the formula I suggested. Hopefully you wrote something along the lines of this. for a two-tailed test where p equals 2 or smaller than 0.05 and n is 9, the calculated value, 0.808, is greater than the critical value, 0.700. Therefore, the result is significant and the null hypothesis is rejected. There is a significant relationship between map reading and driving skills. You made it to the end of the lesson. Hopefully everything made sense, or is making at least a little bit more sense, and I will see you again in the next lesson where we learn how to calculate the sign test. Thanks for watching.